Every week, it seems we read about how scientists have found a gene that causes a disease, like diabetes or heart disease or cancer. Usually, scientists have looked at the genes of a lot of people with a particular disease and figured out which genetic variations occur most often in people with that disease, and less often, or not at all, in the genes of people without the disease.
I think that there's two things. One, when we see those headlines that identify a specific gene related to a specific disease, that's really only providing us one piece of the information that we need to understand. So we may have identified one gene variant related to having someone be at risk for a specific disease. But there's so much other information that goes into making a decision with regards to what happens to an individual and whether they get the disease, or is the disease severe, or differences with regards to how the disease progresses within an individual. So we just are at the tip of the iceberg, is the way I would describe it. And there's so much that's underwater that we need to learn to better understand how we can use genetic information to help to improve the health of individuals.
Genes work to cause disease in many ways. For some genes, like Huntington disease, everyone who has the misspelled gene will get the disease sooner or later. This is also true of cystic fibrosis and hemophilia. But for some genetic diseases, not everyone gets sick, even if they have the misspelled gene. Some may get very sick, some may have mild symptoms of disease, and some may not develop disease at all.
It so happens that when we have studied the Mendelian single gene defects, that those mutations are both necessary and sufficient for a disease to occur. That it appears in those disorders, such as say in sickle cell, that the environment is almost unimportant. Even there it's not unimportant, but it's almost unimportant in the sense that if a young person has 2 copies of the sickle cell mutation, that they will eventually suffer some of the consequences of sickle cell disease. This is not the case for almost all of the common illnesses of humankind, where there may be various ways in which even a malfunctioning gene, that malfunction can in fact be mitigated so that one individual may be unaffected with that disorder, whereas some other individual may be much more unlucky and in fact come up with that disorder, say such as hypertension. And in fact, the object of genetics is not to keep this at the level of guesswork, but figure out which environment acts on which genes in which way, so that we take the luck out of it and can predict it with much greater certainty.
For example, DNA misspellings are associated with breast cancer, but in a very complicated way. The average woman in the United States has about 13% risk of developing breast cancer in her lifetime. Women who inherit a misspelling in a gene called BRCA1 face a much higher risk of breast cancer, 80% chance over their lifetime. But not every woman with a misspelled BRCA1 gene develops breast cancer. Scientists believe that women's risk can also be raised or lowered depending on diet or exposure to chemicals in the environment or workplace, or even how well other genes work to help keep the body healthy. These factors can also raise or lower the risk of breast cancer in women who don't have the BRCA1 misspelling.
So for example, we know that there are mutations in a gene called BRCA1 and 2 that cause breast cancer in some women. But there's a lot of breast cancers that are caused by a lot of other genes that we don't know anything about yet. And even in those 2 genes, not always does someone get breast cancer if they have a mutation in those genes. So we're looking at a whole host of other genes, and we don't know how they interact with one another. We're looking at environment, we're looking at what way a woman grows up, what she eats, where she lives, and all the other things that might contribute to getting breast cancer at the end of the day.
One of the areas in which medicine has really figured out a great deal, and that is not to say that there's not much more to learn, is in the area of cardiovascular disease. And in cardiovascular disease, we know of specific behaviors and specific aspects of the environment, that is diet. We know the role of exercise and many such factors that impact on the risk of cardiovascular disease. This is also an area where primarily for the cholesterol-related disorders, we also know the effect of single genes that impact on the risk of cardiovascular disease. So cardiovascular disease now represents a very fruitful area for further inquiry for additional reasons as well, because now we can image the heart and various vessels in our body that are part of the cardiovascular system with much greater accuracy and much greater fidelity than we could do before. But cardiovascular disease represents one area in which we know many of the environmental factors, we know some of the genes, and a much more comprehensive study that can take individuals across various layers of the society and can put them in a study to try and see which factors impact on the risk of which individuals in which precise manner.
What scientists and doctors need is a large and powerful study that helps them look at all the genes, all the environmental factors, and all the lifestyle factors for disease all at once.
But in the past, we haven't really had the strong genetic tools to be able to assess how these individuals differ in terms of their heredity. Now we have the chance to do that. So an ideal study would bring all of this together, would use new methods that we have for assessing environmental exposures, whether it's diet or physical activity or air or water, what's there, as well as these new, very powerful tools to look at individual genetic differences. And if you had that opportunity with a very large number of people that you could follow over time and find out who stays healthy and who gets sick, you would be able to put all this together and finally really get the answers that we've been looking for.